Hi everyone, so welcome to week 1 of online learning for our little Psych 2100 lab. I'm going to try to keep these lectures fairly short, just to, make everyone's life easier and not make you stare at a screen and listen to my voice any longer than you have to. But of course, if you have questions, there are a number of ways that you can ask them. You can email me, you can talk to me during virtual office hours, we can schedule a time to talk, or there's the discussion forum thread on Husky CT. So today we're going to be talking about prepping your data or cleaning your data just to get it ready to actually analyze. And then we're going to be talking about just a quick review of sort of all the statistical tests we've talked about so far. So if you haven't yet watched the lecture on factorial ANOVAs, I'd recommend watching that, especially if you think that's something that you're going to need for your study. Okay, so just talk about sort of cleaning your data and kind of prepping your data. This is unfortunately one of the more tedious and boring parts of data analysis, but it's also probably the most important part, just making sure that your data is organized and clean before you do any kind of actual statistical analyses. So there's a couple things that you're probably going to have to do. Obviously, if you have certain cases in your data that are not covered here, we can talk about it individually, but these are kind of the broad strokes. The first thing is that you're probably going to have to do some reverse coding. So reverse coding is where you take certain items or certain questions of your scale and you essentially flip the response patterns. So for example, if you have a depression scale and one of the items is I experience joy regularly, you may have to flip the responses so that if someone answered a 7, it then becomes a 1. If they answered a 6, it then becomes a 2, so on and so forth. So that then essentially higher scores indicate more depression. And this just makes sure that all of your items in a scale are kind of going in the same direction. So for example, a lot of you are using the Rosenberg self-esteem scale. There's definitely some items in that need to be reversed so that higher scores will indicate greater self-esteem. This is really easily done in SPSS. You do not have to do this by hand. In fact, I would not recommend it. And there's a video on Husky CT about how to do this. The other thing you have to do is you're going to have to actually score your measure or your scale. If it's a pre-developed scale, like for example, the Rosenberg self-esteem scale, or if it's a depression scale or something like that, you should definitely look at what the author says to do. So you can do this by either finding the original paper for that scale, or sometimes even just some Googling where you just type in the name of the scale and then scoring will tell you how to do it. Some of these scales have what are called subscales, which means, maybe 4 or 5 items actually make up, one facet of whatever it is you're trying to look at. So maybe it's, state self-esteem versus trait self-esteem or something like that. But the instructions will also tell you what items need to be reverse coded and such as well. So that's just kind of a good place to go to in general when it comes to cleaning your data. If you have a scale that you developed yourself, you definitely want to just make a very conscious plan for what you're going to do with your data. So there's sort of no real right or wrong way most of the time about what to do with your data. If you have multiple items that you want to sort of put together into one scale, just make sure that you think through it thoroughly and you sort of have a plan and you write it down and you write that logic down so you can refer to it later. Generally, people tend to either sum or average their items. If you have a choice, average is probably better than a sum because it's not as affected by missing data or people who just don't answer some of the questions. But again, if the scale that you got from you have a pre-developed scale and the author says to sum it, you can sum it. And again, talk to me if you're unsure about things. Okay, another thing that you might need to do is if you have categorical data, things like academic standing or gender, you need to turn them into quantitative data, so numbers that you can actually analyze. If you do this in SPSS, it's really important that in the values column of SPSS, you make a note of what each of those quantitative values mean. So if you have a 0, 1, and 2, you make sure that you actually have a note somewhere to remind you that 0, 1, and 2 means, for example, low, medium, and high, because you're probably not going to remember that when you come back to this in a week. I already did this for your data, at least I'm pretty sure. If you get your data and you think I missed something, let me know, but I'm pretty sure I already did this. So I think you can pretty much just skip this step. And then last but not least, if you have any sort of scales with multiple items, so more than one item trying to get at the same idea, you will need to find a scale reliability. Typically, we use Cronbach's Alpha. So I mentioned this a number of weeks ago and told you just to kind of like tuck it away in your brain for now or back then. But you will need to calculate this now for all of your scales. What scale reliability does, it just kind of tests to make sure that participants are answering in some kind of a consistent way. So, for example, they're not just putting sevens all the way down if there's reverse scoring. They're not saying they're depressed in one question and then say that they're really happy in the next. Things like that. It's basically just a way to make sure that your measure is actually sort of, I should say that participants are responding in a way that they are expected to with your measure. So again, can be done in SPSS, and actually, even though you're analyzing this, it's actually put into the measures or the materials section of your method. So I told you all to put placeholders in the method. So for this Cronbach's Alpha, so that's where this would go. So on Husky CT are all of these resources for how to do stuff in SPSS. There's a whole folder of SPSS resources, in fact. There's a Word document with sort of step-by-step instructions for how to do a lot of this stuff. That was written on an older version of SPSS, so some of that might be a little bit out of date, but it should at least get you pretty well through. There's also video tutorials that I just linked in from YouTube for how to reverse code variables and how to calculate Cronbach's Alpha. Also, your SPSS assignments that you've done so far have the most up-to-date instructions for running these tests because I've gone through and updated them with the newest version of SPSS. And then, of course, you can always ask me. You can check in with your group mates. And of course, Google has 8,000 resources for anything you could want with SPSS. Okay. So just briefly here at the end, I want to kind of review all of the tests that we have talked about in class, sort of what your toolbox of statistical analyses are, and just make sure we're all sort of refreshed and on the same page about what tests end up going along with what type of data analysis. So we've gone through 4 kind of tests so far: correlations, t-tests, ANOVAs, and then the last one's the factorial ANOVA. And like I said, be sure to check out the other lecture posted in the Lab 8 folder about that. So just as a reminder, correlations are used to look at how 2 different continuous variables are related or associated with each other. So of course, continuous means that they're on sort of a continuous number scale. There's a minimum and a maximum. So these can be things like age, GPA, weight, and we also consider Likert scales to count as correlations. If you're, really paying attention in stats class, you might tell me that Likert scales are ordinal. They are, that's true, but we're going to count them as continuous well enough for correlations. So Likert scales count as well. T-tests are moving away from the realm of continuous variables and into the realm of categorical variables. So t-tests simply just test any kind of differences between 2 different groups. So you have to have a categorical variable to separate your groups. So for example, it might be men versus women. It might be experimental condition versus control condition. And then your outcome variable is going to be a continuous variable. So for example, if I was interested in gender differences in just social media exposure, I might look at women versus men, and I might have my outcome as social media exposure. And I can do that with the t-test, again, because it's two groups. As soon as you have more than two groups, you get into the land of ANOVAs. So ANOVAs are very similar to t-tests in that you're still looking at the effects of a categorical independent variable, some kind of a grouping variable, and looking at the effects on a continuous dependent variable. So let's say I was interested in amount of existential crisis feelings in college, and I wanted to look at it across sort of year in college. So because we typically think of college as being 4 years, not for everyone, of course, but let's say it's 4 years. So I'm now beyond two groups. I can't use a t-test anymore, so I'm going to have to use an ANOVA. So I'm going to divide up my participants into 4 different groups: freshmen, sophomores, juniors, and seniors. And I'm going to measure them on the continuous outcome variable of existential crisis. So I have the categorical grouping variable of their year and the continuous variable of existential crisis feeling. And last but not least, we get into the factorial ANOVA. And so again, I go into this much more in the other lecture video, but just as a reminder, a factorial ANOVA is where you have 2 or more independent variables predicting a dependent variable. So at least one of those independent variables has to be categorical, but the other one can either be the other independent variable can either be continuous or categorical, but the outcome is once again continuous. So let's say I was not just testing for college year in terms of existential crisis, but also major, like what major people are in. So I would have one categorical independent variable that I can group together of year, and then another categorical variable of major. And my continuous outcome variable can be existential crisis. So I can look at just both the independent variables separately in our main effects, as well as the interactions of those 2 independent variables for the existential crisis. So factorial ANOVAs are what happens when you have more than one independent variable. Okay. So if you have any questions, definitely email me. You can also post it to the FAQ discussion forum on Husky CT. That way I can answer your question, and also everyone else can see the answer to your question as well, which is probably going to be very helpful for your classmates. And then don't forget, I have virtual office hours Wednesdays from 2 to 4 p.m. Eastern time. And you have a Google Hangout invite in your email in a little calendar invitation for that. So feel free to be in touch if you have any questions about this. I'm happy to answer them, and we will talk soon. Thanks so much, everyone. Stay healthy, and talk to you later.